Hello everyone and welcome to Software Fundamentals Part 3. Today I'm going to show you how to optimize a compound. First of all, from the homepage of SCIEX West, we're going to go to MS method. We're going to go to New, Guided Optimization and MRM Infusion. So we'll open the Ready panel first of all, and you can see that we've got our SCIEX 7500 system connected. We've got a green tick here which says it's operating and working well. We've also already started the syringe pump, so we're just going to go ahead and optimize the compound. So the first thing to do is put the compound name, and today we're going to look at Ametryn. The precursor mass, which is 228, and then the number of fragments to use. So today I'm going to use 8 fragments because I know the qualifier transition is a little bit less sensitive, and so I want to make sure we capture that within the method. So we go to continue. And then because I've chosen automatic, everything is now essentially going to be done for us. So we can see the precursor mass at 228, so we can see that, and we can see a relatively flat line for our TIC, which is what we want to see. Let's move down so you can see that a little bit better. And then if we click on next, because we're happy that we've got a flat line there for the TIC, it'll then determine the product ions for us. So it'll ramp our collision energy. As we can see our precursor mass, and we can start to see our fragments as our collision energy increases. So what we want to see is the dominant transition, or the dominant fragment, which is 186, which we can see nicely here. And then we should also see 68, which is our qualifier transition that we typically use. And we can see those in the list of different fragments here as well. So just wait till that cycles through. And now it'll move on to optimizing the collision energy for those. So it's determined the fragments, and now it's going to optimize the collision energies for each of those different transitions. So again, we just wait till it cycles through. With automatic, it does take a little bit more time than guided, because with guided you can actually determine the window, what collision energy you stop at, what collision energy you start at. So if you know the compound really well, then you can also go into guided to make this a little bit quicker. But otherwise, as we are waiting here to cycle through the different collision energies, from 10 from the ramp start up to 180. With a small compound like this, it's very unlikely we'll ever need to go anywhere near 180. And so like you can see, most of the transitions it's determined, and we've already got a nice Gaussian peak, which is what we're typically wanting to see with these compounds. So now we'll just wait till it goes up to 180. Okay, so we're at 180 now, and now we're going to move on to optimizing the collision cell exit potential. And so again, we just essentially wait until it gives us the optimum value for our CXP. And you'll notice the difference here between CE and CXP. CE, we typically get a more of a Gaussian peak. Here we get more of a sort of flat line, as we can see, which, unless it's really out of an optimum value, doesn't make too much difference in the, to the sensitivity of the MRM transition compared to a difference in CE. Okay, so that's finished now, and we've created the report. So we'll press continue. And then what happens finally is it opens an MS method with all of the transitions and the optimum values within it, which you can then change and add new compounds to, or tidy up a little, so you can remove these and call it Ametryn 1, Ametryn 2, Ametryn 3, etc., etc. But that's it for part 3 of software fundamentals. Thanks a lot for listening, and I'll catch you on the next one. Bye, everyone.